Great to see you here again. This is another video in the Chapter 1, Foundations of Logic and Proofs. In the previous video, we looked at negating quantified expressions. And in this video, we will be looking into translating English sentences into logical expressions. I already spoke about it many times, translating sentences or conditions that we express in natural languages and not only English have to be translated in a correct logical expression, and that logical expression should be true in all possibilities, in all cases. Now, in the course we refer to English, but of course when you are dealing with a different language, you have to use that language to translate it into these logical expressions. Now let's have a look at translating sentences. And this is, like I said before, it's very important to look at it. Natural languages typically have some ambiguities, and it is very important that when we translate them into logical expressions, that these ambiguities are disappearing. Logical expressions and their translation into natural languages, or natural languages and their translations into logical expressions, has to be unambiguous. Now, there are examples in languages where small changes in a sentence can change the total meaning of that sentence. And it's also so that in some languages, different words have different meanings. Or, for example, in Dutch and Flemish, both are basically the same language. They have the same dictionaries, they have the same grammatics, they have the same words. Some words in Holland or in the Netherlands have a different meaning than what they have in Flanders. And these are things that have to be taken into account and makes the translation of sentences in logical expressions rather difficult in some cases. In this video, we're going to look at some cases, we look at some real sentences, and we try to find their logical expression. The first example here is, in fact, that we have to look at those expressions and translate them step by step to identify the predicates that are in that sentence and the quantifier that we have to use. So basically we have to identify the different predicates here and the quantifiers, the universal or the existential quantifiers that we will use, and also some logical functions like implication and or negation and things like that. Let's have a look at a sentence. And this sentence says that every student who passed my class of project management has enough knowledge to work as an assistant project manager. I'm also teaching courses in project management, and basically the course is designed to bring young people, young professionals, experienced professionals, to bring them the essentials of project management. It can be used by people who are already in project management, but basically when I look at high school or when I look at university, these people typically don't have any project management experience, and at the end of the course they will have the basic experience. They are not ready 100% to be an independent project manager, although they can do that for smaller projects, but for larger projects they can act like an assistant project manager and be a valuable team member. Now we can translate this into a different sentence, and we're going to try to translate this so that we can identify the different quantifiers and predicates. So basically what I can change in this sentence is to translate or to change every student. I say, for every student who passed my class of project management, that student has enough knowledge to work as an assistant project management manager. So I look at for every student, which is typically an identification of a quantifier. Passed my class of project management is typically a predicate, and the student has enough knowledge is also a predicate. And now we have to translate this where we put the variables in there. And here we can say that for every student X who passed my class of project management, X has enough knowledge to work as an assistant project manager. Now, when we look at these elements here, we see that we can finally translate it for all of X. For all of X means all the students in my class. The assistant project manager predicate for X is true. So basically it means for the domain of all my students indicated by X, the APM, the assistant project manager function, is true. In fact, we have the universal quantifier and that predicate. Now we can look at a different domain. Here we looked simply at the domain. We said the domain is the students in our class, which already makes that we are looking at that typical group of students. We're not looking at other students. We're only looking at the students who are in fact part of my class. Now we can expand this. We can go for a wider domain, but that also implicates that we have to put additional conditions there. Let's now change this statement. We have the original statement: for every student X who passed my class of project management, X has enough knowledge to work as an assistant project manager. And now let's consider X to be all the people or all the students at the university, and then we have to adjust the statement as follows. For every person X, if person X passed my class of project management, then X has enough knowledge to work as an assistant project manager. So now we are expanding, in fact, the population. X is not just the number of students anymore, but it can be any person. And basically we say that if that person passed my class, then that person has enough knowledge to work as an assistant project manager. Here we have to add an implication. So the final result here is that for all X, for every person, S of X means passed my class of project management. So if S of X, then APM of X, it means when the person passed my class, which is the predicate S of X, then APM, the predicate APM of X, is true. So basically, we have an additional condition here. We have an implication which says if a person passed my class, then they are in fact good enough, they have enough knowledge to work as an assistant project manager. Let's have another example of translating sentences. And I look at some friends of mine has visited, or some friend of mine has visited the gorillas in Rwanda. I don't know if you know the story, but there is a very nice movie, Gorillas in the Mist, with Sigourney Weaver, who is going to defend the gorillas in Rwanda, and she became very famous, and many people visited the gorillas there in the national park. I've been there also. I got a lot of nice experiences, and basically, of course, I have also some friends who visited the gorillas in Rwanda. So basically, this is a true statement, and we can translate this as there is a friend of mine with the property that the friend has visited the gorillas in Rwanda. So now here we have the quantifier, there is a friend. The property, the predicate, is in fact the friend has visited the gorillas in Rwanda. And we can continue with this, and we can put the variable in there. And we can say there is a friend of mine, X. X is the indication of the friend, with the property that X has visited the gorillas in Rwanda. And here the domain X is the set of people who are in fact part of my circle, part of my friends. And now I can translate this as R of X has visited the gorillas in Rwanda, so that's the predicate. And basically when we look at the statement, I didn't have enough space on the previous page, so I come here to the property, we coming here to the quantifiers, and basically we can say R of X has visited the gorillas in Rwanda, and it means that there is an R of X, there is an X, R of X, who is in fact a friend who visited the gorillas in Rwanda. This is an existential quantifier. There is one or more, there are friends, but it's only one or more. It's not all of my friends who have visited the gorillas in Rwanda. I could say all the people in the group that I visited the gorillas in Rwanda with visited the gorillas, which is in fact always true because all those people were in my group, and it would be a complete different sentence. But this sentence is closer to reality. Now, when we go to this statement and we extend the domain, and now we can say there is a person X having the property to be a friend of mine, X, and X has visited the gorillas in Rwanda. Now, these are the elements that we can translate. Again, the domain is now wider, and we have f of X is a friend of mine, that's the first predicate. R of X has visited the gorillas in Rwanda, and we can now say that there is a person X for which we have the statement that f of X and R of X is true. When it's a friend of mine and he visited or she visited the gorillas in Rwanda, then this is true. We can also say I have a friend, a person is a friend, or visited the gorillas in Rwanda. That would make a different statement, then the and would change in an or. So we have here a conjunction, and then it would be going to a disjunction. So this was the element that we considered. Now we are going to finish this video. We looked at these examples. There were a few examples that we have. We will see in the chapter that we will have more examples in the different paragraphs. In the next session, we will discuss quantifiers in system specifications and logic programming. You're doing a great job. Step by step, we're getting there, video by video. I'm looking forward to seeing you in the next video. Thank you and bye-bye.